Picture this, a brilliant blue light show dancing across the sky of a distant ice giant. And in 2025, we might just get our clearest view ever of Uranus's spectacular auroras. When we think of auroras, we usually picture the northern lights here on Earth, those shimmering green curtains dancing near the poles. But what if I told you there's a planet out there with auroras so different, so mesmerizingly blue, that they make our light shows look downright ordinary? Welcome to Uranus, the ice giant that's about to become the star of our solar system in 2025. Unlike Earth's predominantly green auroras caused by oxygen atoms, Uranus's auroras glow in spectacular shades of blue and ultraviolet. The secret lies in its atmosphere, which is rich in hydrogen molecules. When charged particles from the solar wind interact with hydrogen high in Uranus's atmosphere, they create this otherworldly blue glow that's visible mostly in ultraviolet light. But here's what makes 2025 so special. Uranus is approaching a unique orbital position that happens only once every 42 years. You see, Uranus rotates on its side, tipped over at a crazy 98-degree angle. This means its poles take turns pointing toward the sun during its 84-year orbit. In 2025, Uranus will be near equinox, meaning both poles get equal sunlight, creating optimal conditions for studying its auroras. Scientists are particularly excited because we now have more powerful telescopes than ever before, including the James Webb Space Telescope, which can peer through the cosmic darkness to capture these celestial fireworks in unprecedented detail. The blue color isn't just for show, it tells us crucial information about Uranus's magnetic field, which is both tilted and offset from the planet's center. This creates a magnetic environment unlike anything else in our solar system. Imagine a magnetic field that's essentially doing cartwheels as the planet rotates, creating chaotic but beautiful auroral patterns. Recent studies suggest these auroras might be more powerful than we ever imagined, with energy releases that could potentially influence the planet's weather patterns and atmospheric chemistry. What's even more fascinating is that Uranus's auroras don't just appear at the poles like Earth's. Because of that extreme axial tilt and weird magnetic field, they can show up in unexpected places, sometimes even near the equator. This makes predicting and observing them both challenging and thrilling for astronomers. As we approach 2025, observatories around the world and in space are preparing to turn their instruments toward this distant world. The data they collect could revolutionize our understanding of how planetary magnetic fields work, especially for ice giants, which we now believe might be the most common type of planet in our galaxy. But here's something that might blow your mind. We've only directly observed Uranus's auroras a handful of times. The Voyager 2 spacecraft gave us our first glimpse back in 1986, but that was before many of our current technologies existed. Since then, we've had to rely on occasional observations from Earth-based telescopes and the Hubble Space Telescope. 2025 represents our best chance in decades to study these phenomena with modern equipment. The timing coincides with Uranus being relatively close to Earth in its orbit, making observations clearer and more detailed. Amateur astronomers with powerful telescopes might even catch glimpses of the increased atmospheric activity, though the blue auroras themselves require specialized equipment to detect. What makes this particularly exciting for planetary scientists is the potential for discoveries that could apply to exoplanets. With thousands of ice giant-sized planets discovered around other stars, understanding Uranus helps us interpret what we're seeing in distant solar systems. The blue auroras of Uranus aren't just a pretty light show, they're a window into the fundamental processes that shape planetary systems across the cosmos. As we count down to 2025, keep your eyes on the news from space agencies and observatories. They'll be sharing images and data that could change how we view this mysterious ice giant forever. Who knows what secrets Uranus's blue Borealis might reveal about the workings of our solar system and beyond? What planet's phenomena fascinate you the most? Drop your cosmic curiosity in the comments below.